In this video, we're going to go over the final exam review on the problems bar. So the first question says, solve the equation for the exact solutions over the intervals 0 to 2 pi and show all the key steps in the solution. So the first exercise about this gives me an equation where we have cosine of x times cotangent of x plus cosine of x equals 0. As always, with this type of equation, what you want to do is you want to factor out the common terms. So for example, in this case, it will be cosine. So cosine of x is a factor of cotangent of x plus 1 equals 0. Then this is going to provide you with two opportunities for solutions. One is going to be where cosine of x is equal to 0, and the other one will be where cotangent of x plus 1 is equal to 0, or where cotangent of x is equals minus 1. Now, from cosine of x equals 0, you get two solutions. You can use either the unit circle or you can use your calculator. You're going to obtain that that's pi half and also 3 pi half. Of course, this is where the unit circle cosine is the coordinate x in the unit circle, and that's going to happen at 90 degrees and at 270 degrees, which coincides with the point where the x coordinate is 0 on the unit circle. So you have the unit circle, pardon my picture, you have this point here and this point here. Those are the 2 points where the coordinate x is 0 with the unit circle, and they coincide with the angle x equals pi half and x equals 3 pi half. Now for cotangent of x equals minus 1, you can kind of flip this around, and you can also see this as tangent of x equals minus 1 as well, because remember cotangent is 1 over tangent, and so you can just flip around the equation. And this is essentially telling me, hey, tangent of x is equals minus 1. So that's almost being equals 1. And remember, tangent of x is equals 1 when sine and cosine are the same. In this case, we're saying that they're the same, but that they differ by the sign. So where is that going to happen? Well, that happens in the pi over 4 points, right? So this will provide me with 3 pi over 4 and 7 pi over 4. And those will be the 2 points where this has cotangent of x equals minus 1. A similar type of equation is b, where we have sine of 2x equals the square root of 2 cosine of x. But in here what's happened is that you do a little bit more because you have to do the double angle identity. So sine of 2x is 2 sine of x cosine of x. And now is equals to square root of 2 cosine of x. Now you put that square root of 2 cosine to the other side. And so you have now this. Again, cosine in here is also the common factor. And so you have cosine of x factor of 2 sine of x minus the square root of 2. Okay? And then this is going to give you two things. Either cosine of x is equal to 0, or this is equal to 0. 2 sine of x minus the square root of 2 is equal to 0, which in turn is sine of x equals the square root of 2 over 2. And then again, cosine of x equals 0 means x is equals pi half, 3 pi half, and sine of x equals the square root of 2 over 2 is pi over 4 and 3 pi over 4. Okay, those are the two possible points where this achieved this number. Now, question number 2 is about inequalities. We've been discussing this a lot in class. The significance of the absolute value is the distance of x to a point. So if we're going to solve this, we want to isolate the absolute value. So we leave here x plus 2, and I'm going to leave this 4 here for now. But we're going to do 10 minus 6, right? And so this is going to be equals 4, of course. And so the next step, we're going to be able to divide by 4 on both sides. And we're going to have x plus 2 less and equal than 1. Now, with that, something happens that we can use the rule, or we can imagine what geometrically this means. By the rule, we get that x minus 2 is between minus 1 and 1, and then we're going to add 1 to everything. Sorry, we're going to add 2 to everything to cancel out this 2. And so if we add 2 to everything, we get that x is between 1 and 3. And that, of course, is going to coincide with what we have geometrically, because this is saying the distance to minus 2 should be less than 1. And so when we pick the numbers that are away and that are less than 1, sorry, this is plus 2 here. This is plus 2. So I need to do a minus 2 here. And so minus 3 and minus 1. Okay. Gotta be careful with the signs. Now, if we are distance away 1 from minus 2, of course that's gonna give us minus 3 and minus 1, which reflects with this. That kind of helped me see the mistake that I was making for getting the plus in here. So checking with the distance is always an important thing. Now, for the second one, we have 3 absolute value of x minus 8 minus 7 bigger than 29. We can do the same thing, 3x minus 8. I'm going to move the 7 to the other side, and this becomes a 36. I'm going to divide by 3 on both sides, and then this becomes a 12. So the distance of x to 8 must be bigger than 12. And so we have 8 in here. And so points that are 12 away from 8 will be 20 and minus 4. And so those points are going to be away. And we want to take the points that are bigger. So this is telling me, hey, minus infinity to minus 4, union 20, infinity. And then we can actually check this with the rule. The rule x minus 8 bigger than 12 means two things. Means that x minus 8 is bigger than 12, in which case this means that x is bigger than 20, or x minus 8 is less than minus 12. And now for question number 3, we have the equation of the circle, and we want to put that equation of the circle on the canonical form of that equation, which is the x minus h squared plus y minus k squared equals r squared. Now the procedure for that is going to be completing the square. And so for example, for this part, x squared plus 4x, we're going to add the division by 2 of this term. So 4 divided by 2 will be 2, but we're going to add the square of that, 2 squared. Now for y here, we have y squared minus 6y. And again, we're going to divide by 2 this 6, which is 3, and we're going to add 3 squared. Now, if we're adding on one side, then we got to add to the other side. So we have 0 here, and we add this 2 squared. And then we add this 3 squared. Notice that we have this minus 6 over here left, so we're going to have to move that one in the next line. So now we can fold this to being x plus 2 squared, and I can fold this part to be y minus 3 squared. Remember that the sign comes from this sign here, from this and this sign. And now this is 4 here plus 9. And this minus 6 here goes to be plus 6 here, and this would become 19. So now at this point, then this is x plus 2 squared plus y minus 3 squared equals, and then because the radius is the square root of 19, I can write this as the square root of 19 squared. The center of this is, of course, minus 2, 3, and the radius will be square root of 19. Now for question number 4, we're going to find the missing sides and angle of the following triangles. And so we have, we can make a picture here of a given triangle. And so we have B, let's call this one B, and it's an angle of 35 degrees. We have the opposite side, which is 4, and then we have, let's call this side A, which we don't know, and that's corresponding to this angle here, A. And of course, we have this angle and this side C. So to be able to find the remaining angle, then we're going to use law of the sine. So we're going to do sine of A over A, that we actually do know is not this, is actually 6, right? And that's going to be equals to sine of 35 over 4. Okay. And so we have sine of A over A, but A is 6, so let's replace that by 6 here. And so at this point, we can find out how much that's going to be. And from here, we're gonna get a couple options. Since we're getting essentially that A is sine to the minus 1 of 6 over 4 over sine of 35. Then we need to find out what this is going to provide. And depending of the angle that we obtain, we either going to have one or possibly two triangles. So let's use Desmos calculator to find what that value is. So we can compute sine of 35. And just make sure, of course, that when you're using your calculator, you must be sure that you're using degrees, right? So here, if I'm using the Desmos, I can set up here the options, make sure that I'm doing degrees. And so now that I have this, then I can put the 6 over 4 in front. And now I get that this is 0.86 CR3. Notice that this is kind of familiar. This value is kind of familiar. This looks like a square root of 3 over 3. Or maybe not. But this value looks very familiar. It is now the square root of 2 over 2, right? But anyway, so now what we're going to do is we're going to get sine to the minus 1 of this. And so now this is telling me that I'm getting 59.4. And so A here is 59.4. But notice that that was a 0.86. And so this 59.4, it leaves the option for me to have a second A that I can find. And because I'm finding signs and positive signs, then in the unit circle, positive signs means that I'm finding this value. So it has one value here, which is probably this one, 59.4 degrees, and it has this value here. So there's going to be a second A possible, which is going to be 100 and 80 minus 59.4. And that's going to be 120.6. Now notice that with this A and this B, I'm going to have two triangles. Triangle number one is going to be A being 59.4, B being 35. And so now the complement is going to be the side C, right? And so the side C here is going to be 95.6. And this is my triangle one. And with my triangle number two, then of course I have A2 being 120.6, B is 35. And so in this scenario, if I find my C2, which is going to be this minus this, I'm going to find out that this is 34.4 or 24. This is 120.6 plus 35 minus 180. Yeah, this is 24.4. And so those are the values that it gives me for the triangles. Now what is left is to find the side C though. But I can find that in each of the cases. So I can do C over sine of 95.6 equals to, and so I can use any of this scenarios. So I can use sine 4 over sine of 35 from this side, and that's gonna give me the C. And similar in this case, I can have C over sine of 24.4 equals to 4 over sine of 35. And with this, I can find both of the triangles that this will give me. Now, question B has the information in all the sides. Notice that this is giving me all the sides of a triangle. And so what that means is essentially that I have a triangle that I don't have angle information. And if I don't have angle information, then this is calling for the law of the cosines. Okay. And then we can call this one is angle A. This one is angle C. And this one is angle B. Remember, this angle is opposite to the side. And so now we need to find just a single one of these angles. So for this, we can do, let's say, 8.5 squared. So A squared is equals to 10 squared plus 12.5 squared minus twice 10, 12.5. And then this will be cosine of A. Right? This is one of the approach that I can use. It's not the only one, of course. When you're doing law of the cosines, then you can do with whatever angle can be feasible. So for example, I can also do it with the side B. So 12.5 is equals 8.5 squared plus 10 squared minus twice 8.5 times 10 cosine of B. And so if I'm going to find out what this is, then B here, or whatever with A, if you prefer. B will be cosine to the minus 1 of all this quantity, so that will be 12.5 squared minus 8.5 squared as well, minus 10 squared divided by minus 2, 8.510. And so now if we put that in the calculator, then this should give me a single angle. In this case, this is going to be 84.6. And I can do pretty much the same thing to find the cosine of A. So from this equation, then I find that the cosine of A is going to be certain value. And then I use the inverse. And so from this case, I can find, oh, okay, so A is going to be 42.6. Same process of this, but instead of A, instead of B, use this equation for A. And once that I have this angle and this angle, then I can subtract from 180 both this angle, and I'm going to find that this is 52.8. Now at this point, I'm going to have the three angles and I have the three sides, so that will completely fill all the things I need to find from this triangle. Now last but not least, we have this type of triangle where we have information that is incomplete, but we have certain pieces of the puzzle and certain angles and certain sides. So the first thing that you can do with this is try to figure out all the information that is possible from what is given. So initially notice that we want to try and find the angle DCV, which is this angle over here. This is first what we want to find out. And we have information that this CVD, which will be this one, is 21, and we have that ACD is 18. We have that this is 8, this is 10. Okay. Now to find the angle DCV, we can use law of the sines. Right, so we're gonna find this one, and so we can use the fact that we have 10, right? So we can find sine, and let's call this alpha for simple ways of calling this. So sine of alpha over 10 is going to be equals to the sine of 21, which is the one that we have information here, and the opposite is 8. Okay, so with that we can find out that alpha is going to be sine to the minus 1 of 10 sine of 21 over 8. And this is going to provide me with 26.6. Okay, so now that we have this one and that we know that this is 26.6, then we can find this angle over here. I have this one, 26.6. I have 21 here. So this one, to complete the 180, will be 132.4. But because I can also complete 180 here, then this is going to be 47.6. And now that I have 18 and I have 47.6, then I have this one, which is going to be 114.4. So that pretty much completes all the angles that I need to find information. Then at this point, I want to find out AD, which is this value here. And I can do that with the law of the sines now. I have this side, this angle, and I can use this angle and this side. So AD over sine of 18 is equals to 8 sine of 114. And that's going to give me the value of AD. So if I compute that, that means that AD is going to be around 2.7. Now similarly for BC, which is this big one, I can use BC over the sine of 132.4 equals to, let's say, 8 over sine of 21. And notice that, so the most important part here was finding out who the angles were. And once that I had the angles, then a simply law of the sines is going to help me out find all the other values that I need. All right, so this is the end of part A of the problems. See you in part 2.